Geometry, Chapter 3, Lesson 5, still looking at polygons. We've been looking at the interior angles. Now let's go ahead and look at the exterior angles. And here it says if you draw an exterior angle, and remember we talked about exterior angles last lesson, and remember an exterior angle is formed by a side of the polygon and then the extension of the adjacent side. So if you were to draw one at each vertex, what would all these add up to? We have a way to figure out what the inside ones add up to. We've been doing n minus 2 times 180. But what about the exterior ones? Do they add up to anything in particular, or is there a formula? So if we do this exercise or kind of look at each one of these, if we add these three up, it equals 360. If we add these three together, that equals 360. If we add these three together, they equal 360. And in fact, the polygon exterior angle sum theorem says that if you draw one exterior angle at each vertex and you add them all together, they will always equal 360 degrees. So there's no formula to remember here, no n minus 2 or anything like that. It's just simply remembering that if you have one exterior angle at each vertex and you added them together, that's always going to equal 360 degrees every single time. Okay, so that's the polygon exterior angle sum theorem. All right, now we want to talk about regular polygons real quickly. An equilateral, and lateral, remember sides, so all the sides are the same measure. An equiangular polygon means, again, equal angles, has all angles congruent. If you have a polygon that has both, where all the sides are the same measure and all the angles are the same measure, we have a very special polygon called a regular polygon. And this is going to be very important because we're going to be using regular polygons quite a bit as we go further. And most of the polygons, when we create things or actually build things, are regular polygons. We don't really use polygons where sides are different shapes. Sometimes we do, but most of the things that you see, products that are built, we're looking at regular polygons. So these become very important. And the important thing to remember here is that everything is equal. The sides are all the same measure and the angles are all the same measure. So real quickly, if we were to break that down into our definitions, a regular polygon has equal sides and equal angles. Okay, so we want you to make sure that you remember that. All right, all the angles and all the sides are the exact same length. Now that becomes very important because when you have a problem like this, if you want to determine the measure of one interior angle and one exterior angle of each regular polygon, we need to remember this very important fact, that because it's regular, all the angles are equal. And if everything's equal and we know what the sum is, all we have to do is take the sum and divide it by how many angles we're dividing it amongst. Now that sounded very confusing as I was thinking about it, so let me just say it again and try to clear things up. Imagine if I had 100 M&Ms and I had 10 students in my class and I wanted to give everyone an equal share. How would you determine how much I would give each person? Well, you would take the total, which is 100, and divide it evenly among the 10. So 100 divided by 10, so each person would get 10. Let's say I had 100 M&Ms, but I had 25 students. How many would each student get? Well, I still would take the total, and then I would divide it again by how many people am I giving it to? 25. So 100 divided by 25 would be 4. Well, when we're talking about angles, or angles and sum of angles, in regular polygons, we know how to figure out the total that all the angles inside add up to, n minus 2 times 180. So that gives me the total number of degrees that I have. And I need to, in a regular polygon, divide it evenly to all of the different angles that I have. So if I have 360 degrees, and I have a four-sided figure, which means 4 angles, and it's regular, all 4 angles have to get the same amount of degrees from my total. So I take my total, 360, and I've divided by the number of angles, 4, so each angle has to be 90. Or if I had 360 degrees, but I'm looking at a 5-sided figure, well, because it's regular, all the angles are equal, so each angle has to get the same number of degrees from the total. So I would take 360 and divide it by the number of angles that I have, 5. So 360 divided by 5 would be 75, right? 360 divided by 5. 5, 7, 31, 72, excuse me, 72. Okay, so when it comes to doing a problem like this, we need to know what the sum is, what the total is, and then we just simply divide it by how many sides we needed to have in our polygon. Now remember, the interior angles, the sum is determined by doing n minus 2 times 180, and exterior, remember always, the exterior always add up to 360, so you would simply have to do that. So that's kind of a long explanation, but basically it comes down is if you know the total, you divide by number of sides. And the total for the exterior is always 360, so you divide by the number of sides. So let me do an example or two, and then hopefully that will wrap up what we're doing here. So if I want to know the measure of one interior angle and one exterior angle of a pentagon, how do I figure that out? Well, for the interior, I need to know what the total is first. So the total, penta is 5, so 5 minus 2 times 180 will give me the total. So that's 3 times 180, so that's 300 and 240, so that's 540 total degrees inside the polygon, pentagon. And we know that it's 5, so I'm going to divide this by 5 to give me the measure of just 1. So that's going to be 108 degrees for each angle on the inside. Now for the exterior, again, I need to know the total. Well, that's always 360. And again, there's 5 sides, so divide that by 5, so that's going to be 72. So one interior angle would be 108. One exterior angle would be 102. Again, the key here is you need to know the total. So you got to go back to the polygon angle sum theorem and remember what the exteriors add up to, and then simply divide by the number of sides. So let me do another one for you. What about a dodecagon? Well, a dodecagon, you remember, is 12 sides. So again, for the interior angle, I need to know what the total is first. So there's 12 sides minus 2 times 180. So that's 10 times 180, so for a total of 1,800 total degrees. And because they're all even, each one I divide by 12 then, so that's going to be 150 degrees for each interior angle. Okay, 150 degrees. I think I did that right. 1,800 divided by 12, that's 1, with 6 left over is 60, that's a 5, even, yeah, 150. Now, for the exterior angle, again, I need to know the total, so the total is 360, and then there's 12 sides, so that's going to be a measure of 30 degrees each. So each one is 30 degrees. Okay, so again, it goes down to doing total. Make sure you indicate which one's interior, which one's exterior when you do that. I'll do one more, or maybe 2 more if you'd like to continue watching. If you think you got it, just go ahead, skip to the end, and go ahead and tackle your homework. But I'll do a couple more. Okay, what about 100gon? Ooh, 100gon. Well, again, I need to know what the total of the interior is first. So, same thing. It's 100 minus 2. That's pretty messy. Let me fix that up. So again, it's a total 100 sides minus 2, and then we're going to multiply that by 180. So that's going to be 180 times 98. So that's going to be, I'm going to use my calculator for that one. 98 times 180. So it's going to be 17,640 total number. And we have 100 sides, so we're going to divide that by 100. So that goes off, move the decimal point over. So each angle is going to be 176.4 degrees if you're looking at an interior angle. For the exterior angle, again, I need to know the total, but the total is always the same, 360. And divide by 100, so move the decimal point over 1. So each exterior angle is going to be 3.6 degrees. Okay, I think I have one more, so I'll try to do that one. What about an 18gon? An 18gon. So again, for the interior angle, I need to know what the total is first. The total is the number of sides minus 2 times 180. So that's going to be 16 times 180. So that's going to be, I'll do that on my calculator. I should really do it in my mind. But so 2880, that's the total, and there's going to be divided evenly among 18 angles because it's regular. All the angles are the same. So each angle then is going to be 160 degrees for an 18 gon. Now, for the exterior, again, I need to know the total. Total is always 360. So divided by 18, so that's going to be 20 degrees each. So each one's going to be 20 degrees. Okay, so this only works again if it's regular polygon because all the angles are the same measure, so they get divided evenly. So again, you're just practicing using that same triangle or polygon angle sum theorem to get the total divided by the number of sides because they're all the same, and that's going to give you your measure of your one interior angle, and then the total on the exterior is always 360, and again divided evenly among the number of sides of the polygon. So that will wrap this lesson up. So hope that was helpful, and we'll see you in class.